Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to talk about the union and intersection of sets. So basically, when you talk about the union of sets, it is denoted by this notation. So it is the collection of sets where it consists of all elements in that particular collection. So mathematically, the operation can be written as A union B. So we are talking about two sets union together. And it says here that we are going to consider the elements of X, where X is either the element inside set A or the element inside set B. And so, other way of representing the union of sets is going to be A or B. So, yeah. Alright, so that's the idea of union of sets. Now, let's look at the idea of intersection of sets. Now, the intersection is normally denoted by this symbol here, and it is a collection of sets such that the set contains all elements of A that also belong in B. Mathematically, the operation can be written as this one. So A intersects B, where you are going to consider the elements X here, where X must belong in A and it must also belong in B. So the key word here is AND. And we can say that sometimes the process of saying A intersects with B, A intersects with B is denoted as A and B. So the keyword here is AND for intersection and OR for union. Okay. In terms of representing these two ideas using the Venn diagram, you can see we have got here two sets, and when you talk about the intersection of two sets, so let's say this is set A and set B, the intersection of two sets here denoted by A intersects with B is represented by the area over here, where this area here contains the elements that belong in A and also it belongs in B. So this is the overlapping area where you have elements for both A and B. Now, if you look at the idea of union of sets, so we have got A and B. So A and B is the union of sets A and B here. We are referring to everything that is in A and also in B and also in this area where you got A and B together. So that's the union of two sets. Right, now let's look at this simple example here. We have set A consists of 2, 4, 6, 8 and 10. Set B is 2, 3, 5, 7, 9 and C is 10, 15 and 20. And the universal set is defined to be the values from 1 to 20. And the question is specifically asking you to represent all the sets here in a Venn diagram. So that will be your first step. You have to construct a Venn diagram to represent the scenario given in this example here. So now we're going to start off by constructing a rectangle. Yeah, so this is the rectangle that represents the universal set. Okay, so this is the rectangle. It represents the universal set, and universal set consists of these values over here. So you can see that roughly you can see that here we got set A where the elements here are shared 2, 2, and then we've got another set over here where C here they don't share any similar elements with C and B, but you can see that 10 here is also included in set A. So roughly you get the idea of how you can construct the circles inside this rectangle here. So basically we will have set A somewhere here. So this is set A, and we've got intersection between A and B. So this is between A and B. So we've got set B somewhere here. And then we've got another set, set C. You can see that here we've got the same element that is shared. So we know there is an intersection as well. So this will be set C. Okay. So those sets are represented by circles. Now we're going to list all the elements. Well, here we've got 2 and 2, so they share the same element here, so it will be represented in here 2. And then we've got 4, 6 and 8, so it will be 4, 6 and 8. And 10 over here is shared with C, so we've got 10 somewhere here. Next, we've got 3, 5, 7 and 9, so 3, 5, 7, 9. And then finally we've got 15 and 20, so this is 15 and 20. Now other values that are not included in set A, B and C will be outside of those circles. So here we've got maybe this is 1, so 2 is here, 3, 4, 5, 6, 7, 8, 9, 10. Next we're going to have 11, and then 12, 13, 14, 15 is here. So now we move on to 16, 17, 18, 19, and 20 is over there. Alright, so now our Venn diagram is complete. We have represented all the values related to A, B, C, and other elements that are not included in those circles. Right, so next let's talk about using this Venn diagram to find the value for this process that we've got over here. So first we're talking about the union of A and B. So the union of A and B can be represented as this area. So this is the union of A and B. Yeah. So therefore, the answer to union of A and B, A union B is going to be all the values inside this purple shaded area here. Okay, so I'm going to write down accordingly. It will be 2, sorry, it will be 2, 4, 6, 8, 10, 3, 5, 7, 9. So this is the answer to the first question here, the union of A and B. Next, let me just erase this area. Okay. So next is the intersection of A and C. So the intersection of A and C refers to the area where you have an overlapping between those two sets. So this is the area of intersection for A and C. And so the answer to that is A intersect with C is going to be just equal to, there's just one element there, which is 10. Yeah. So that is the second question. Next is, let me just erase that. Okay, so next is this part here, where you have the complement of set A intersect with B union C. So this can be translated as A intersect with B union C, and you want to find the complement of that. So this is slightly complicated, but I'm sure we can do it. Okay, we're going to start with finding what is this area first. We're going to start with finding the area of B union C. Where is the area of B union C? So B union C refers to this area, B union C, B union C. So this area. Okay. Now, what is the area of A? So A is this part. This is A. This is all A. Okay. So now we want to consider this yellow area intersect with this black area. So this is intersection. So intersection is where the yellow part and the black part here intersects, and we can say that this is where the intersection happens. Yellow with black and yellow with black area. So this area. So this is the area that we are looking for, and this red area here represents the whole thing here. So the red area that I have shaded here represents the whole mathematical expression given here. A intersect with B union C. Okay, so now the question is not asking you for this value. The question is asking you to find the complementary of the red area. So now we're going to find this part, the complementary of the red area. So what is the complementary of a set? The complementary of a set are the elements that are outside the red area. So where are the elements that are outside the red area? So these are all the elements that are outside the red area. Yeah, so everything that is outside the red area. So we are talking about the complement of the red areas. So we are talking about all the elements that are outside the red area. And so the answer to that question, to this question here, which is A intersect with B union C, the complement of that is going to be everything else. So it's going to be I'm going to start, sorry, let me just do this. Sorry, let me erase this. So it's going to be, I'm going to start off with this one. So 16, 17, 18, 19. So 18, 19. Next, I'm going to move on to this part, 15 and 20. 15, 20. Next, 4, 6, 8. So we've got 4, 6, and 8. And then 3, 5, 7, 9. So we've got 3, 5, 7, 9. And then we've got 1, 11, 12, 13, 14. So we've got 1, 11, 12, 13, 14. So this is the answer to the third question here. Alright, I think that's all for now. Thank you very much for watching.